Hello, welcome back. Right, I'm very happy to have Rajan Krishna with me now.
Hi.
Martin, do you want to introduce yourself?
Yes, my name is Rajan Krishna. I work on the Windows developer marketing team.
Right.
And I'm going to be talking about Microsoft Passport and Windows Hello today.
Yeah, this is cool stuff, huh?
Yes, definitely. So it's you want to dive right into it. So Andy mentioned it in the beginning. There's a I would say an epidemic almost about cybercrime in
too many reports. Huh?
Yeah, I mean, like I have a couple of examples here. They're just from the past month or so.
Yeah.
I mean, these probably look familiar, but it's basically the problem that we have with passwords currently, right? So they get hacked. People, they get all these issues.
Yep. And everybody has all these bad practices. It doesn't matter, we tell people they have to change passwords, but you have to remember them, and people write them down, and then. That aside, they're insecure anyway in the way they're used, but then we get the problems with databases being hacked with these things on them, and it's a big problem that we need to get a better way of doing this, don't we?
Exactly. So some of the challenges you mentioned, there's a couple here on the slide. So basically, credential theft is a big problem. So phishing is definitely, you've probably seen one of those emails, someone asking you, hey, you should reset your password on this specific website, which is not actually the website that you should be visiting. You enter your password, and basically they have your credentials.
Have you had those phone calls? They ring up and say, "I'm from Microsoft." Support.
Oh yeah, definitely.
Everybody gets those.
That's bad as well, and we do a pretty good job of warning people. We're never going to ask you for your password, but still, it happens a lot. One of the other challenges is credential reuse. So because passwords are inherently complex, you have to change them every so often. People tend to use the same password for multiple sites. So even though you're maybe used to having a good infrastructure on Facebook, for example, they should have their security in line. If you're using the same password on some little unknown obscure website, they have your password, and they can sort of guess, and they can sort of try that on all these different types of sites as well. We talked about password complexity and expiration. I mean, it only makes it harder for the user to keep remembering that password, because they have to put all these special characters, and it has to be a minimum sort of length, and people forget, so they write them, paste post-its all over their desk so everyone can see their password. It's becoming a real problem. So on the user end, there's all these different challenges, but also from an IT perspective, if you are an organization or identity provider, there are definitely problems with using passwords. You have to supply all these different mechanisms for resetting passwords, making sure that it gets refreshed every so often, et cetera, et cetera.
Yeah, so it's a complex problem.
Definitely. Yeah. So luckily, there's already a solution for this problem. You may be already using this two-factor authentication or multi-factor authentication. In this case, you augment your password, which is something you augment that with something you have. So in most cases, it's going to be your mobile phone. A lot of identity providers provide this functionality where you may be logging in on a new device, and it asks you, hey, I'm going to send you a code via SMS, or I actually open up an app and it generates this code for me, so I can use that code as a second factor. So basically, no one can guess even if someone guesses my password, it's useless because they don't have the associated code, which changes every so often.
So there's kind of two things, because I work remotely, and I'm connecting through VPN, and every time I connect to Microsoft VPN, I actually have to pick up my phone, and I get an authentication, a push notification comes through, and in this special app I have to put a PIN code in. So again, it means it's not only the device where I'm logging on, but then I also need to have the phone as well. So this is this two-factor thing.
Yeah, exactly. So in some cases, it's something you already have, right? So your smart card could be one of those things, or you probably know those in enterprise environments. There's these little USB keys that you plug into your PC, and it generates a code for you, and you enter that code. The challenges with that is obviously the increased cost of managing that whole infrastructure. You need to be able to send text messages, or you need to manage an additional app with all that infrastructure in it. Plus, it's more difficult to use for users. They don't only have to remember their password, they always have to have their device with them.
Security comes at a price, and you've got to kind of hit that sweet spot between good security and minimal user inconvenience. So they've got to buy into this and sort of say, yeah, okay, I'm happy with this because of the improved security we have.
Exactly, and that's exactly right. I mean, most identity providers like Facebook, Microsoft, etc., they offer two-factor authentication. The actual usage is less than it probably should be because of this increased inconvenience to users. So the thing that we're trying to do with, coming back to Microsoft Passport and Windows Hello, the thing that we're trying to do is really, make the internet a safer place by getting rid of passwords altogether. So no more passwords, which is good. You might be wondering, how am I going to authenticate? So we'll dive deeper into that. So introduction to Microsoft Passport and Windows Hello. Windows Hello might be the thing that you as a consumer may have heard a lot about. Windows Hello, logging into your PC, using your face, etc., etc. Microsoft Passport is something that we actually introduced in Windows 10 as well that powers all these experiences, and there's really the authentication engine behind it. So let's split them up and let's talk about how these two work together. So as I mentioned, Microsoft Passport Windows Hello, it's really a convenient way to do multi-factor authentication. The two parts that are in play, so Microsoft Passport, which is an enterprise-grade type of authentication mechanism. It's embedded into Windows, so basically once you have Windows 10, you have Microsoft Passport capabilities with your operating system. It works in conjunction with the hardware trusted platform module, the TPM chip that's in all of the phones basically that we're releasing right now, and in most laptops. It's a secure storage. BitLocker is one of those things that also uses a TPM chip to store all these different keys. I think this morning
TPM is tamper-proof, isn't it? So it resists, attacks.
Exactly. Yeah, and it's a physical thing in your device, so it's very hard to get to. I think this morning you went into being able to store the encryption keys for Microsoft Passport in there. Yep. So Microsoft Passport really uses asymmetrical keys. So it stores a private key inside of the TPM chip on the device, and it has a public key which you then can hand out to different users, and they can basically take that public key and validate that whatever message you sent them has been signed with that private key that's on the device.
So this thing about, when you set it up, first thing it says is, okay, you need to set up a PIN.
Yes.
So to most end users, they're thinking, well, how can a number, entering a number, be more secure than entering a full password?
That's a very good question. So once you set up Microsoft Passport, and we'll go through the experience within Windows, but if you set it up, it will actually ask you for a PIN code to set that up with. So you might be wondering.
That happens on the phone as well. I set up my Lumia 950 with the iris detection, and that's just the same. It's the same stuff, but the first stage is to create this PIN code. Yeah,
so first, basic use case, even if you don't have any additional hardware, you use Microsoft Passport with a PIN code. That PIN code can be complex. IT organizations, they can require a certain complexity, length, etc. But it is the basic premise of a PIN code. The reason why the PIN mechanism is going to be safer than using a password is because it's used in that combination with your actual device.
Yeah.
So it's not just a PIN.
Password's used in isolation, but here we're talking about PIN plus device. That together, when you set it up, it generates that key pair, the private public key pair. And if anybody's not familiar how this thing works, it's the kind of bedrock of network security. But the idea here is that the private key goes into your TPM. It's kept secure in there and used only by the system, by Microsoft Passport, in order to digitally sign things. But the public key, you can paint that in letters 6 foot high on the wall. It doesn't matter. Anybody can learn what your public key is. But the thing is, and they need it, because what will happen is the server will send a challenge back, and your machine will digitally sign it with the private key, send it out, and then they can use the public key to check that has really been sent by the holder of the private key of that key pair.
Exactly.
This is the basis of it all. Yeah.
Exactly. So view the PIN and basically the biometrics of Windows Hello, which we'll go into, but view that as the unlocking mechanism, basically, of getting into those private keys on the chip. So that's the only way that Windows will give you temporary access to those keys, so you can do something with it, sign them, etc. Yeah. But that PIN really protects the hardware, and that combination is what makes it safe. So the PIN on itself, it doesn't matter if it's 1, 2, 3, 4. I could tell you my PIN, you're not going to be able to use anything unless you have my actual physical device. Yeah. So Windows Hello is the biometric engine that's inside of Windows. So right now, I think this morning you explained it as well, we support facial recognition, iris scanning, and actual fingerprints. So in this machine, I have a Intel RealSense camera embedded. It's embedded in this Lenovo Yoga. So basically what I can do is I can use my face to gain access to that TPM, to those private keys as well. If for some reason that might not work, I can always fall back to using that PIN. So that framework is what we built into Windows. these are the type of things, type of sensors that we have right now and that we, are in the world. Nothing stops you from creating, your own type of sensor. If you want to go completely nuts, you can say, I want to take a blood sample from you and then actually use that to authenticate you. Probably not a good idea to do that, so don't try that at home. But you could definitely do that with the Windows Hello framework. So Windows Hello, really the biometric part of it, and Microsoft Passport is the actual authentication piece that's working with it.
Yeah.
So Microsoft Passport for Work, you may or may not have heard about this. So Microsoft Passport for Work is something that we offer on top of Microsoft Passport, and it's really designed to integrate with your existing enterprise or business infrastructure. So if you have an Active Directory in your organization, or you're using Azure Active Directory, for instance, you can use Microsoft Passport for Work to really optimize that experience that you have for work. So what you do is, once you have Microsoft Passport for Work, those keys are also stored in that Active Directory. So anyone can basically that has any application that has a trusted relationship with your Active Directory, they can get access to those keys and enable scenarios like single sign-on, for instance. Yep. So every time you unlock it with your PIN, etc., that still has to happen, obviously, because you are the second factor. It gets unlocked in Azure Active Directory, and I can sign into whatever system that I need to sign into. What it also adds is group policy management, so your IT organization can really fine-tune that those requirements that you have for using Microsoft Passport. So, for instance, in our case, on my Microsoft machine, I cannot use a PIN that's 1, 2, 3, 4. Actually, it needs to be at least 6 characters long, and it cannot be a sequence.
Cannot be sequential, yeah.
It's a little bit more secure in terms of a PIN code, so no one can really guess it. Even if they had access to my device, the PIN is a little bit more complex. So the out-of-box experience, like I said, in Windows 10, in the November update, if you actually start your PC for the first time and you log into your machine with either a public Microsoft account, which is your Outlook or something, email address, or you're using Azure Active Directory, you will see an out-of-box experience that asks you, hey, do you want to make your computer more secure?
We've got this nice friendly, passwords are so yesterday.
Exactly. So this is the way where we're trying to educate users, basically. Hey, this is actually a good thing. You can enable this on your machine to be more secure. And there's even a link up there.
Yeah, I was going to say, even right up here, it addresses that kind of concern, saying using a PIN is faster and more secure than a password. We hope you'll love it. How can a 4-digit PIN be safer than a long password? And there's a link there that should take people to explain that.
Yeah, and it really explains those two parts of why this is more secure. So if you click on that button, you will be asked to set up a PIN code on your machine. If it detects any hardware, so my other machine actually has a fingerprint sensor, so it asks me, hey, you want to enroll any of your fingers in this machine, so you can actually use Windows Hello to use that unlocking.
And the Lumia 950s were into.
It's going to do the iris scanner, exactly, and this one is going to do the facial recognition. Yeah. So let's take a look at how that looks inside of Windows. So let me really quickly open up the Windows settings. So it's really an end user setting in here. You go to accounts, you go to sign in options, and in here you will see obviously my device is enrolled into the Microsoft infrastructure, so you'll see some of the settings are managed by my organization. In here I've already set up my PIN. So once you set up the PIN, I can change it, but this is basically what enables Microsoft Passport. So it creates that container inside of the TPM chip for those keys to be stored. And in here it says, hey, I can actually use Windows Hello. So I can set it up. It says, hey, my device got more personal. I can learn a little bit more. It actually detects that I can use my face, so I can actually use it to buy things in the store as well. Instead of entering my password every time, I can just sit behind my desk and it will recognize me.
That's a good point, isn't it? Because this is an indicator to the store is just an app, and and we'll get onto this, as an app developer building apps with security authentication built in, can also add this Windows Hello authentication into Microsoft Passport into your app.
Yeah, you can totally extend it, and we'll go into a sample that does that. So if I click on getting started, it asks me to enter my PIN code to make sure that it is me. It will actually enable the camera, and with this awesome lighting up here, it might look a little bit overblown, but and it says, hey, I'm all set. So it recognizes my face right now. I can actually improve recognition, so I can remove my glasses and tell it, hey, if I don't have my glasses on, also recognize me, or if I, at some point decide to shave my beard, I want it to recognize me as well. So I can improve that, and the system learns from all these different configurations of yourself, basically, that you will have. But right now it's set up so I can actually close it. You can see I can always go back to improving that recognition, or I can actually remove it. In here you will see some settings saying, hey, do you want the system to automatically unlock the machine once it detects you? If not, like in a corporate setting, maybe on my laptop, it's not a good idea to always sign in immediately to have my desktop show. I can actually have it ticked off, and it will detect me, but I have to manually dismiss that lock screen, basically, to sign in. And there's an additional setting in here that says, hey, you know, your organization requires stricter requirements, so I have to actually turn my head left and right to actually make it detect. So it's a little bit more elaborate.
Kind of odd, that one, isn't it? Yeah.
Yeah, it's shaking. So I turn it off for this demo purpose, but you will basically just turn your head left and right to make sure that it detects all sides of you, and it really has that intrinsic detection.
Cool.
So that is everything you have to do basically with setting up that PIN. So right now my machine is configured using Passport. It's configured with Windows Hello using the camera as well. So to your point, you know, the store is just an app inside of Windows 10. So any app can basically use that third-party library that we have to use Microsoft Passport in your actual app. So there's a couple of steps that you need to do if you want to enable this. So let's say you are creating a totally new solution. So you don't have any existing infrastructure, you don't have an existing password management system, you want to create a new one. Let's say I want to create a new identity provider for my specific purpose. These are the things I need to do. So in my app, I need to enroll or sign up a user and their device. So basically the change here is you're no longer in the registration process, just ask the user for their name, their username, their password, etc. The password is going to be definitely going to be skipped. But you also need to detect that actual device. So me logging into this system can only happen from this device at that moment. So once that's done, I signed up, I registered everything on the server end. I need to authenticate, obviously, with Microsoft Passport. So I can use that PIN, or I can use Windows Hello with the biometrics. And I need to provide some kind of mechanism, like someone can go to a web portal and see all their devices that they've enrolled. They can actually, you know, unenroll them if, you know, some device gets stolen, for instance. I can actually make sure that it's secure.
Yeah, so this is a refinement on the kind of forget me thing that a lot of client server apps would have had in the past.
Exactly.
Now it's not only forget me, it's kind of forget me and this particular device, the two-factor authentication thing.
Exactly. Yeah. So how that works in APIs, so if you want to enable Microsoft Passport, you see a little bit of a flow chart on the left side. So the first thing, there's an API to actually detect whether or not the user has set up their PIN. So once they set up their PIN, this actual method, so the key credential manager, is supported async. That will return true. So you can actually say, hey, you know, this user is ready to use Microsoft Passport in my application. If it returns false, you can ask them, hey, you know, enable that PIN on that machine so we can actually continue to do this. Yeah,
it's a nice, easy API, isn't it? It's got like 4 methods.
Exactly.
Key credential manager. You'd think something like as complex as this would be mind-bogglingly complex, but it really isn't.
We made it really easy for you to use Microsoft Passport in your app.
That's right,
so the second step is going to be, I need to create that credential key and an attestation. So the attestation is basically going to be a cryptographic algorithm that allows you to detect whether or not that key has been created inside of that TPM. So there's a couple devices, obviously, that don't have that TPM chip. If not, Microsoft Passport will still enable. It will use a software implementation that we have in Windows. Obviously, it's going to be a little bit less secure, but you can use that attestation to basically detect, okay, has this thing been created inside the TPM chip, or is it, you know, is it a software mechanism? Whether or not you want to do anything with that information, that is obviously proprietary to your implementation. So you can use this request create async method. This will pop up that same dialog, you know, asking me for my PIN or actually my face, and it will create those keys inside of the TPM chip.
So let's get this right. So this process, the request create async, basically will chain onto Windows Hello and say, okay, authenticate this user on this device again. So whatever way you've set up the face, that you set up face pass.
Exactly.
And as a result of that, we get a key pair generated, and we store that private key away down into the
so the API actually does all that for you. So everything is going to be stored on the machine. You can request the public key part of it, and that is the second thing, the last thing that you need to do. Obviously, you want to get that public key, get that attestation, send it off to your server together with the user information that you captured, and then store that on the server end to really be able to validate that user. So on your server-side database, obviously you are not probably not equipped to handle this mechanism right now.
So yeah, this is a slight refinement on what's in the past. You'd have a user identity and presumably their password, but now in your user-side database, it's the user and that device. So
Exactly.
you need to have that stored. Yeah.
Yeah, so it's going to be a one-to-many relationship because
Yeah.
a user can have more than one device
Yeah.
that they enroll in this system.
And each user device combination is represented by the public key that was generated on that particular device when you actually
Exactly.
enrolled
Yeah.
for this app.
So in this case, this is a very simple diagram of how that actually might look. So I'm going to have a collection of user keys for any user. And basically, I'm going to have a device ID to go with that because the user should be able to recognize that device. So in that example, if I have a web portal where users can unenroll their device, they need some way to identify the device, obviously. So you can store that stuff on there. So a lot of talk about the implementation. Let's just show you how that works in enrolling a new device and a user. So up here I have a sample. The sample will be published next week on GitHub in the Windows Universal Samples repository, so you'll be able to get this.
Yep.
It consists of 3 projects. So there's a client project, obviously that is the app that we're going to be using. There's a models project. It's a portable class library. It basically contains a number of different classes that are shared between the server and the client, so it's going to make things easier. Just going to collapse that for now. And there is a server part to it, which in this case, because it's a sample, it stores everything in memory, so it's going to store the users and the devices. But this is the actual server, so we can actually see the entire flow from the client to the server and back, and how that interaction method works. So let's run it first, and let's see what it looks like. So starting this project or the solution is going to start up obviously the server and the client at the same time. The first time it might take a couple seconds for the server to actually boot. Once you see this screen, it basically means, hey, the server has started and I can actually start using that client. So in this client, it's a demo, Woodgrove Bank. I already have a relationship with the bank. I've signed up, obviously not through an app, for a banking app. So in here, I can actually log in. This bank has an existing infrastructure of taking usernames and passwords.
Yep.
So that's what I'm actually going to do. This is me using the app for the first time. In the sample, you can use any username and password. Basically, there's a little hint that shows up for you that you can just enter anything that you want. So I'm going to enter my information, and this is where that first API that we talked about actually kicks in, and it detects that I've set up.
Actually, this system supports Windows Hello, so at this point, the client-side app will invite the user to use this because this is it would be a more secure way of
Exactly.
Going forwards. Yeah.
Yeah, so we get a nice little friendly message for the user, really telling them, hey, you can you can start using Windows Hello. It explains a little bit about it. Again, we included those links in there, so if people are starting to doubt, why is a PIN code more secure, that same problem we talked about earlier, we recommend that you also, make them aware of the fact that it's not just a PIN code; it's a combination that they have. In this case, if the user clicks maybe later, this is where you would do your normal authentication flow. So you would use username and password.
This is kind of using yesterday's technique,
Yes,
and
exactly.
still credentials are flowing across to the server. They do the authentication.
Exactly. So obviously, if you have an existing system, you don't want to switch to Passport overnight. Not everyone, unfortunately, has.
That kind of would probably be a bad business move.
Yeah.
Just email
by the way,
you need a Windows 10 system. And
yeah. So, but you give them the opportunity to basically enable Windows Hello in this scenario. Again, very specific in this sample, we talk about Windows Hello because that is the thing that end users are familiar with. Microsoft Passport isn't really a notion that they understand because
underneath.
Windows talks about Windows Hello as well. So I can say start using Windows Hello. It will turn on the camera.
This is the system-generated
Exactly.
UI.
So you can see my app is in the back there. This is Windows actually taking care of the detection. So Windows, it actually recognized me. It tells me, okay, select OK to continue. So it detected my face. I can always fall back to PIN if I want to.
Yeah.
So if I click OK, basically what happens now, it registers that user on the server side. It registers the user. It registers the device. So it can be used in subsequent logins.
So at this point, what we have just sent to the server was just the user identifier, name,
yes,
and their public key, effectively,
exactly.
and the attestation.
And the attestation.
That's
yes.
right. So that's all. So the PIN hasn't gone across the network. There's no passwords going across the network. That's all it is. It's just
exactly.
the public key, which anybody can see this is public data, and you've sent that out, and that get registered on the database.
Yeah, completely true.
Yeah.
So the PIN is never going to be known by the server because it's only used on your device to unlock that key pair, basically.
Yeah.
So if on the top right, I can sign out, and you can see I also do a registration on this machine, and I can obviously unregister that user, so I can start over again. So let's take a look at how that is implemented in code.
Yeah, you might want to make that a bit bigger, maybe.
Yeah. Whoops. Let me quickly change the font size. Oh, not the font size. If you're unfamiliar with the quick launch in Visual Studio, it's really convenient to get the settings really quickly. So this should probably do it.
Cool.
So in here, I have the login page. Again, very basic example. You've seen the app. It is a responsive design, so it works on phones. It works on bigger screens, etc. So in this login method, I actually have a button in here that says, let me quickly look it up, the first login button click. So in here, basically what I do is what I would normally do. I would capture the user's username, password. I would detect that. And I could do actually my standard registration process if I were to register for the first time with this application, which I'm not going to be doing, but you can actually include that in here. This is that API that we talked about. So in here, I'd actually detect whether or not Microsoft Passport has been set up. If it has, then great. I will be using that account ID. I'll send it to the enable hello page, that second page that we looked at. If it's not set up, actually in this sample, it will pop you a message saying, hey, to proceed with the sample, you need to enable Windows Hello or Microsoft Passport in the settings. It will actually tell you, you can configure Windows Hello, Windows settings, account options, and sign-in settings. Once we do that, we go to the enable hello page. So the enable hello page, what it does is it pops you the dialog explaining all these different things. So again, if you click the later button, this is where you would do your normal verification of user ID and password, which we don't implement, obviously. So start using Windows Hello. This is the interesting part. So the first part is creating that key credential that we have. So looking at this method down here, we use that request create async method basically to create that key pair.
Yeah.
And in this case, we're just giving it an identifier, which is the account ID, which is going to be my name in this case. And I'm going to say, hey, if there's an existing key, I'm going to replace it because I can run this sample multiple times. That actually gets us back a key creation result. It has a status, so you can actually validate whether or not that has been created. If for some reason the hardware is off or something is wrong with the machine, you can actually detect if that's going to fail or not. And you can actually get the credential out of it with the public key.
Yep.
So that public key is what you're going to be using.
That's what we're going to send off to
the server. Exactly. So in this case, I just return true. I go back to where I was. And the second part is going to be registering that credential with the server. So in this case, I'm just going to be pulling the host name for this device. Obviously, you want a little bit more of a elegant solution in your actual production environment. But in here, I'm just going to take the device name. I'm going to create a device info object to send to the server for the device. I'm going to be creating this credential information, basically taking in the public key. In this case, we're base 64 encoding it. It's just for size purposes. No information is lost. The string gets shorter. Win-win solution. And I'm going to be creating a user info, which would normally have, my username, password, or my username, my last name, first name, etc. Definitely not a password.
Okay, cool.
I'm creating a message object. Again, because it's all public data, I can just send this over to the server using a normal JSON object. I don't have to do any special encryption of the message because it's public data that I send over. And I send this over to my API.
Yep.
So taking a look at the server, the API that we're using is register. So going over here, I have a register method, which is this one. I take in the message, I parse in that information that came back from the message. I'm going to be checking if it's not empty or anything strange, and I'm going to be registering that user.
Right.
Basically in here,
that just stores that away into your database.
So this data access layer is going to be in memory. So in here, I have two lists, basically just devices and the users list.
Okay. Yeah.
So that is the registration process that we have. So we enrolled the user into a new device, so now we can do subsequent logins or authentication actually with Passport.
So important thing to say is if somebody is still using the old school method of doing it, subsequent logins, they still need to enter their username and password. It's still flowing over every time, and we're still back in the old school.
Exactly.
But this way.
So this way, it's going to be different because obviously, if your application starts and you know that the user has enrolled with Windows Hello, what it's going to do is it's going to request a challenge from your server.
Yep.
So this challenge. It's basically something that you create as part of your implementation.
Mm-hmm.
In our case, we're going to be doing a very simple way of generating a random number, added on with the date, etc., to make it a unique challenge. The challenge will go back to the client. So I'm going to be using this API to sign that challenge with that private key pair. So this again will pop up that message dialog saying, hey, you need to authenticate with Windows Hello or Microsoft Passport, and it will sign that message for me. Once that is prompted, I sign the challenge and I send it back to the server. The server then validates that challenge using my public key.
Yep.
So it can actually know if I was
Yep.
the actual person that signed that challenge.
Yep. So if anybody tampered with it in transit, then it wouldn't decrypt, and so it's easy for the server to know, oh no, this is a
exactly,
a
and the server would just say, hey, this challenge is not well signed, so either try again or something happened in between. And then if it's valid, it authorizes the user. And this is basically where your normal flow would work, right? So if in your current solution you use a token, you give the user a token to do subsequent calls, API calls, that would still apply. If you have some other mechanism, that would still apply as well. So again, really quickly, the client requests information from the server. It gets a challenge back. It signs the challenge. The signed challenge goes to the server. It validates that challenge. And it returns the information to the user. Yep. So let's quickly take a look at the code for that. So let's run the app again and see how that secondary flow works. So again, the server is going to start. I need to log in again. In this case, remember because it's the server, I kill it, so everything is out of memory. So I need to do this again.
Yep.
Normally this would persist, obviously. So it's detecting me. Click OK to continue. Basically, I'm logged in. So up here in the top right, I have a little logout button.
Yeah.
In this case, in the sample, we cache the user, so it's stored in the actual storage of the app.
Yeah.
So if I click on login, it's going to detect me again, and this is where I already have the challenge. So this is actually basically that sign challenge API that I'm using.
We've actually got a question at the moment saying, basically, can the app not show this system-generated UI? Can it work like an Xbox does, and you just get the recognition and it'll?
It's not silent because it's always going to be something where, in any case, if something fails, the user needs to enter their PIN, right? So it's always going to be that this UI pops up, and this is actually what the user will see. This is also a way for the user to get confidence in, hey, this is Windows actually verifying my identity, and not some obscure thing in the middle, which is going to be less secure.
Yeah, so it's a lot about confidence. So I hope that answers the question, Jaron. Thanks for that.
So in this case, I called the signing API, which is what popped at this screen. So again, if I twist my face away, it stops detecting me. So that's again for security purposes. If I click on OK, and I had this problem yesterday, which is apparently something specific to this machine, might be in preview bits, etc. But what it will actually do is it will create that signing. It will sign that message and it will send it back to the server. So let's take a look at how that works in code. And you will understand that flow. So the second time when I'm actually logging in, I'm clicking the login button. In here, I'm just initializing a couple things to really buffer that public key that I'm going to get. I'm going to get the challenge, etc. So in here, I'm going to get that cached user that's in the isolated storage for my device, and I'm actually going to open the existing user key credential. So the key credential is going to be stored. I'm going to open that to really get that status, is verify if that information exists in the TPM chip.
Yep.
So the second step is going to be requesting a challenge. It varies when you will be able to do this in your code. You might want to do it if you just start up the app instantly, or in this case, if the user actually wants to log in. So in this case, it's going to be calling the request challenge API.
Yep.
Again, very simple. It's in this implementation. It doesn't really do anything special. what it does, it creates a new challenge in this case, and you can actually look at our sample implementation. Again, this is not something you want to do in production, but this is going to be using a couple of the cryptographic APIs that we have to generate a random number. We're going to add the date and time, etc., to really create this unique challenge. It's going to return that challenge to the actual app.
Yeah.
I'm going to decode that. It was base 64 encoded, and then I'm going to sign that challenge with the request sign async API.
So this is back on the server side, yeah. We get that challenge. Yeah. This is it. Internally, it's using the private key to digitally sign it.
Exactly.
And the way the async public-private key pairs work, only holder of the public key, which can be anyone, can decrypt that, and they can validate that that's actually has been signed by the right entity.
Yeah. And you don't have to be a cryptographic expert. As you can see, it's just request sign async, and it just signs the thing for you, and it gives you the result. So you don't have to know anything about signing and encryption and that sort of stuff. So once that's signed, I can actually get a status. If the status is success, I'm going to copy that to a byte array, and I'm actually going to send that off to the server as a response, which is going to be the signed challenge. Back on the server side, if we take a look at that method, again, going to be getting that base 64 challenge, creating that response, and I'm going to be able to get that public key that I've stored in my little in-memory database here, and I'm going to be using that to actually decrypt that message in this verify method. So I'm going to use that public key, decrypt that message, validate that it was a challenge that I created, and then I'm going to actually return to the user, hey, this is valid.
Yeah, we're good.
Yeah, exactly. So again, not very complex to use in this scenario. If that all goes very quickly, obviously the sample will be up next week, so you'll be able to take a look at all the data in more detail. So a couple other things you need to consider. This is basically the whole implementation that you need to do. So now my system supports Microsoft Passport, enabled with Windows Hello if users have devices that support that. A couple things that we don't have, obviously, is being able to unenroll specific devices for users. That UI I mentioned, you probably want to create some kind of a web environment where people can actually detect that. Enrolling of extra devices is also going to be something that's different from any system that you have right now, because right now a user just one time they supply you with their username and password, and that is the registration process. In this case, a user will have multiple devices, so if I want to enroll a second device, let's say I have my phone and I want to keep using my existing account, obviously, but I want to enroll that device as well. There's a couple things you can do. A common pattern is I'm going to be able to register my new device, and I have a device which is already registered, which I need to actually validate that. Again, two-factor authentication. So I need my actual device that has been validated to really enable that secondary device.
Cool.
And then lastly, obviously, the secure challenge response. You need to prevent replay attacks and all that security stuff that you're already doing. So again, this is very proprietary to your existing implementation. You probably have some kind of a mechanism for this. You just need to extend it to be able to send the challenge and validate that if it comes back from the user.
Cool.
So that is basically it in terms of Microsoft Passport. So in summary, it's a convenient way for users to do two-factor authentication or multi-factor authentication. There's no secrets on the server, so even if the server gets hacked, no fault, no harm. They know the public key, but that's okay if they wanna know that. And then that's the only thing that you need to actually implement this.
Yeah. It's probably worth mentioning, we as Microsoft, this is just one thing that we're working on. We're working with industry bodies to try and drive passwords into history. We want to get rid of them. So
so we're working with the FIDO Alliance, which is basically a collaboration between a lot of different companies to really make sure that this becomes a good standard and we can offer this across the board. One of the things we're working on is web support, obviously. So if you are using a website on Windows 10, you'll be able to use that mechanism as well to really log into those web environments using this mechanism. Cool. There's a very detailed, one thing I wanted to mention, there's a very detailed developer white paper up on this URL. Okay. So if you want to read like every step that we talked through today in really fast speed, you can actually do that. And as mentioned, the sample will be available on December 16th.
Excellent. Cool. Great. Well, thanks very much, Rajan. That's awesome. Really good. And thanks for watching. We're just going to take a very short break, and then we're going to go into the last session of this very nice little concise developer's guide update, where I'm going to get Shen back, and we're going to look at the Windows Store for Business. So thanks. See you soon.